Welcome to my first video, and this video will be on Newton's first law. I've already wrote down a idea of Newton's first law, and that is that it's an object traveling at a constant velocity or at rest in a given direction will have no net force in that direction. If an object has a net force other than zero, it must be accelerating in the direction of the net force. So let's look at an example of that concept in action. And we'll just start out with a ball resting on a table. And you know that the forces on the ball resting on the table are, of course, the force of gravity and the normal force, or the force of the table holding the ball up. And those forces are equal and opposite to each other. Therefore, force normal plus force gravity equals 0. Thus, no net force, or force net, equals 0. So the ball is not accelerating up or down. There's also, in the x direction, no forces at all. Therefore, the force net in the x direction equals 0 also. So the ball is not accelerating along in the x direction. Well, if we take and draw this again, except this time the ball is rolling, so it's no longer at rest, but the ball is traveling at a constant velocity. The forces on the ball will be as follows. Of course, we still have force of gravity, which is the same as saying the weight of the ball, Fg, and force normal, and they're equal and opposite. So forces in the y direction add up to 0, so the ball's not accelerating up or down. And there's no, as long as it's moving at a constant velocity, we must have to assume there's no friction, and therefore there's no acceleration on the ball in the y direction either. Note that with something that's frictionless, like this ball that's rolling along at constant velocity, we're not able to tell the whether or not the object is moving based on the force diagram. Great. Now let's look at a ball that's rolling with friction, and so we'll present a slightly more realistic example. And so the ball, my nearly flat table here, and so we'll just say that the velocity, so velocity is in this direction, and so there is some friction in this example. The forces on the ball are, of course, force gravity, force normal, and once again they're the same. And the other force in this example is Fk, or the force of friction on the ball. And so that force of friction tells us that the object must be accelerating. And so while the velocity is from left to right, or in the positive direction, acceleration is going to be from right to left, or the negative direction. So we have a positive velocity and negative acceleration in this case. And you know that because those two signs are different, we must have slowing in this example. So this is a short but hopefully helpful tutorial on the understanding of Newton's first law. And most importantly, in the understanding of Newton's first law, is the realization that it applies to everything. There's nothing that it doesn't apply to. You can think of a leaf falling from a tree, or a bowling ball rolling down an alley, or yourself walking to school, or a page in your textbook turning. Every single motion imaginable has Newton's first law applying to it. So it's a concept in dynamics that for most of you will just become second nature, the understanding of the idea that if something's moving, it's and moving at a constant velocity, the forces in that direction will be add up to 0, or net force will be 0. And if it's accelerating, then there must be a net force in that direction. And so this law will apply to pretty much everything we do in this class from here on out. Thank you much for listening.